Meet Maya. She's a sixth grader staring at her homework, and right there on the page, 1/3 plus 1/4. She writes down a bunch of numbers, crosses them out, starts over, and finally just guesses. Sound familiar? Here's the truth. The reason fractions trip so many kids up isn't the fractions themselves. It's one missing superpower, the least common multiple. By the end of this video, Maya and you will never struggle with this again. Let's go. Before we tackle LCM, let's make sure we know what a multiple actually is. A multiple is what you get when you multiply a number by 1, 2, 3, 4, and so on. So the multiples of 3 are 3, 6, 9, 12, 15. They just keep going. And the multiples of 4 are 4, 8, 12, 16, 20. Think of multiples like the times tables. They're your number's whole family stretching out to infinity. Got it? Great, because this is where Maya's light bulb is about to go off. Now here's the magic. The least common multiple, or LCM, is the smallest number that appears in both lists of multiples. Look at the multiples of 3, 3, 6, 9, 12, and multiples of 4, 4, 8, 12. See that 12 sitting in both lists? That's a common multiple, and since it's the first one they share, it's the least common multiple. LCM of 3 and 4 equals 12. That number 12 is Maya's secret weapon, and yours too. Let's see exactly how to find it every single time. Let's learn our first method for finding the LCM, listing multiples. It's exactly what it sounds like. Step 1, write out the multiples of each number. Step 2, scan both lists and circle the numbers that appear in both. Those are your common multiples. Step 3, pick the smallest one you circled. That's your LCM. This method is super reliable and great for smaller numbers. Maya actually uses this method on her homework, and once she tries it, she's amazed at how straightforward it is. Let's practice it together. Here's our second method, prime factorization. This one sounds fancy, but it's actually a superpower for bigger numbers. First, break each number into its prime factors, like building blocks. Then look at all the prime factors that appear and take the highest power of each one. Finally, multiply those together, and boom, that's your LCM. For example, 12 equals 2 squared times 3, and 18 equals 2 times 3 squared. We take the highest powers, 2 squared and 3 squared. Multiply them, 4 times 9 equals 36. The LCM of 12 and 18 is 36. Okay, so why does any of this help Maya with her fractions? Here's the connection. To add fractions, the denominators, those bottom numbers, must match. And the LCM gives us the perfect common denominator. It's the smallest one possible, which keeps our numbers nice and clean. Remember Maya's problem, 1/3 plus 1/4. The LCM of 3 and 4 is 12, so we rewrite both fractions with 12 on the bottom. Now they speak the same language, and we can add them. That's the power of LCM. It's the key that unlocks the whole fraction puzzle. Let's try our first example, finding the LCM of 4 and 6, using the listing method. Start with multiples of 4, 4, 8, 12, 16, 20. Now list multiples of 6, 6, 12, 18, 24. Scan both lists. Do you see a match? There it is. 12 shows up in both lists. Is there anything smaller? Nope. So the LCM of 4 and 6 is 12. This means if Maya had a fraction with 4 on the bottom and a fraction with 6 on the bottom, she'd convert them both to 12ths. Perfect common denominator, found in seconds. Now let's try LCM of 3 and 5. List multiples of 3, 3, 6, 9, 12, 15. List multiples of 5, 5, 10, 15. Scanning both lists, I can already see 15 appears in both. Nothing smaller matches, so the LCM of 3 and 5 is 15. Here's a cool pattern to notice. When two numbers share no common factors, like 3 and 5, which are both prime, the LCM is just their product. 3 times 5 equals 15. Maya noticed this shortcut and started saving herself a ton of time. Now she's starting to see the pattern, and so are you. Let's level up, finding the LCM of 6 and 9 using prime factorization. First, break down 6. 6 equals 2 times 3. Now break down 9. 9 equals 3 times 3, which is 3 squared. Now identify all the prime factors that appear. We have the primes 2 and 3. Take the highest power of each. The highest power of 2 is just 2 to the first power, which is 2. The highest power of 3 is 3 squared, which is 9. Multiply them together. 2 times 9 equals 18. The LCM of 6 and 9 is 18. This method works every single time, even with bigger numbers. Here's the moment Maya has been waiting for. Let's actually add 1/3 plus 1/4 using our LCM. We already found the LCM of 3 and 4 is 12, so our common denominator is 12. To convert 1/3, we ask what times 3 gives us 12. That's 4. So multiply top and bottom by 4. 1 times 4 over 3 times 4, which gives us 4 over 12. For 1/4, what times 4 gives us 12? That's 3. Multiply top and bottom by 3. 1 times 3 over 4 times 3 gives us 3 over 12. Now add the numerators. 4 plus 3 equals 7. The answer is 7/12. Maya just nailed it. Let's try one more challenging one. LCM of 8 and 12, because Maya just ran into this on her next homework problem. Break down 8. 8 equals 2 times 2 times 2, which is 2 to the third power. Break down 12. 12 equals 2 times 2 times 3, which is 2 squared times 3. Now take the highest powers. For the prime 2, we have 2 cubed. That's the highest. For the prime 3, we have 3 to the first power. Multiply them. 2 cubed times 3 equals 8 times 3 equals 24. The LCM of 8 and 12 is 24. Look at Maya go. She just solved 3 in a row. Let's put our LCM of 24 to work. Add 3/8 plus 1/12. Our common denominator is 24. For 3/8, what times 8 gives us 24? That's 3. Multiply top and bottom by 3. 3 times 3 over 8 times 3 gives us 9 over 24. For 1/12, what times 12 gives us 24? That's 2. Multiply top and bottom by 2. 1 times 2 over 12 times 2 gives us 2 over 24. Now add the numerators. 9 plus 2 equals 11. The answer is 11/24. With LCM, adding these fractions becomes totally manageable. You're doing exactly what Maya just learned, and you've got this. Remember when Maya was staring at that worksheet, totally stuck on 1/3 plus 1/4? Now she can solve those in seconds, and so can you. Let's recap your new superpowers. The LCM is the smallest number that's a multiple of both numbers. Method 1, list the multiples and find the first match. Method 2, use prime factorization and take the highest powers. And the big payoff, use the LCM as your common denominator when adding fractions. From confused to confident, that's the LCM journey. You've absolutely got this. Now go show those fractions who's boss. Parents and teachers, this is a great one to practice at the dinner table.